Locate the absolute extrema of the function on the closed interval. Alright, so the first thing I have to do is I have to find all my critical points. And critical points are the endpoints of an interval and also where the derivative is equal to 0. Because where the derivative is 0, I have a horizontal tangent line, which means I have a minimum or a maximum. So first thing I'm going to do is find the derivative. Remember, 1 over x is the same thing as x to the negative 1. So the derivative is negative 1 times x to the negative 2, which is negative 1 over x squared. And the derivative of natural log of x is 1 over x. And so I have to set that equal to 0. And then I have to solve. So I'm going to subtract 1x from both sides. And then I'm going to treat this like a proportion. So I'm going to cross multiply. Divide both sides by negative 1. Subtract x from both sides. And then factor. So the values where my derivative equals 0 would be at x equals 0 and at 1. So those are two of my critical points. And then my endpoints of my interval would also be critical points. And sometimes you'll hear people call them critical points. Sometimes you'll hear them called critical values. I tend to call them critical values, so I abbreviate as CV. And my critical values are 0, 1, 0.5, and 4. So this time we're finding absolute extrema. So that means that in order to find absolute extrema, I've got to use my critical values, test them in the original function, and see what would be my highest y value and my lowest y value. So I've got to evaluate f of 0, f of 1, f of 0.5, and f of 4, because it's absolute. So my function is f of x equals 1 over x plus natural log of x. And since I have a natural log, I'm going to use my calculator to evaluate each of these. And the first thing I notice is if I plug in 0 for x, I get 1 over 0, which is undefined. So that means that my function doesn't exist there, therefore the derivative doesn't exist, therefore there cannot be a maximum or a minimum. So then we look at f of 1. 1 over 1 is 1. Natural log of 1. Natural log of 1 is always 0, so that would be 1. So it turns out I don't need my calculator for that one. Now let's evaluate the two endpoints. So f of 5 would be 1 divided by 0.5 plus natural log of 0.5. And it is approximately 1.307. In AP Calc we round using 3 decimal places. And then f of 4 would be 1 divided by 4 plus natural log of 4. So that's approximately 1.636. So my highest value, my highest y value would be the 1.636, and my lowest y value would be 1. So that means my absolute maximum is 1.636. So I would say the absolute maximum is 1.636 at x equals 4. And the absolute minimum is 1 at x equals 1. And always remember, my maximum is the y value, the location is the x value.